Good morning, students. Last time in the structure of atom, we studied the de Broglie equation or hypothesis, in which de Broglie said that electrons having a dual character, particle character and wave character also. The next is Heisenberg uncertainty principle. The Heisenberg uncertainty principle was given by Werner Heisenberg in 1927. He said it is impossible to calculate position and momentum, that is velocity, of any moving particle simultaneously with accuracy. This is a fundamental theory of physics, that is delta x and delta p is equal to or more than h, where h is a Planck constant, delta x is uncertainty in position, and delta p is uncertainty in momentum, or we can say delta x into delta v is equal to h upon 2 pi m, where delta x and delta v are uncertainty in measurement of position and velocity. So that from this equation it is shown that if we minimize the value of suppose delta x, then the uncertainty delta v will be more, or if we minimize the value of delta v, then delta x will be more. So the product will equal to the constant h upon 2 pi m. That is if we determine one property is definite, then it creates uncertainty in determination of the other property. From the above equation, it is also shown that the value of m is more. That is, if the mass is more of a particle, the hm will be less, then uncertainty should be negligible or very less. So for a bigger particles or bigger objects like ball, stone, etc., if they have a momentum, then their uncertainties in position and velocity will be less. But for a minute particles like electron, this uncertainty is not negligible. For example, for a ball of 500 gram mass, then the value of delta x into delta p is almost equal to 10 to the power minus 28, which is a very less and negligible value. And for electron, the multiplication of uncertainties is delta x into delta h, delta x into delta v is 6.626 into 10 to the power minus 27, that is the value of h, into 2 into 3.14, that is the value of pi, into 10 to the power minus 28, which is equal to the 0.6, approximately 0.6, and the value 0.6 is much more than for electron, so it cannot be considered negligible. If position is known more accurately, that is delta x is very less, then uncertainty in measurement of velocity will be much more. So the theory of uncertainty is important for a minute particle such as electron, proton, etc. Now what is the physical concept of uncertainty principle? The physical concept of uncertainty principle is that for an electron moving in a Bohr orbit around the nucleus, now if we determine its position, we require a microscope to see it, to study the reflected light. The radiation used to determine the position of minute particles like electron are of very small wavelength, that is of high energy, like X-rays and gamma rays. When the light of small wavelength collide with electron, then the Compton effect take place. An electron suddenly changes its momentum and the value of delta V increases. So if we find out the accurate position of a moving electron, then its velocity changes and the value of delta V increases. It is clear from the theory of Heisenberg that Bohr assumption was not correct, that electron rotate in a definite orbit with a definite velocity. Heisenberg said that it is not possible to find out both the velocity and position with certainties. This can be also explained by this diagram. The uncertainty in momentum during determination of position of electron. Suppose this is the nucleus, this here, suppose the electron is moving. We want to see the electron. If it is at this position, then the light of higher radiation is allowed to fall on it. That is the incident photon. When fall on it, then it collide with the electron and the direction of radiation also change and direction of electron also change. So the momentum is changed, and that is the reflected light which we have seen in this microscope. So when the momentum is changed, when it's moving here, then momentum is changed, so delta V will be more. So when position and momentum of electron in any time cannot be known accurately, then we can think of an electron having probable velocity and probability of finding electron around the nucleus. So from Heisenberg model, Bohr model was considered incorrect and the theory of probability was originated. So next will be the theory of probability. Before studying the theory of probability, we will also see the derivation of uncertainty principle, which is delta x into delta v is equal to h upon m. Now, for the derivation of Heisenberg equation, suppose the position of electron at a time to locate is O. Here in the picture is here O position, and now to see this position a microscope is put here and the incident radiations of incident photon, incidence of lambda wavelength is allowed to fall on the electron. When the incident radiation fall on electron, the momentum of electron is changed and the wavelength of radiation also, reflected radiation also change. It becomes from lambda to lambda dash. So the electron is observed by the scattered radiation of wavelength lambda dash. If resolution power of microscope is delta x, then delta x is equal to lambda dash upon 2 sine theta. This is equation 1. Now, the scattered photon enters in microscope between O A and O B. Suppose photon moves in a OA direction. The momentum of photon towards the OA direction is h upon lambda m, because we know that lambda is equal to h upon p and p is equal to h upon lambda dash. So if it is moving in OA direction, the momentum becomes h upon lambda dash, and the momentum of electron, and similarly the moment of electron of OA direction and the component in a OA direction is h upon lambda dash sine theta. The component is h upon lambda dash sine theta. Similarly, if it's moved in OB direction, then the momentum becomes h upon lambda dash, and the component of momentum is h upon lambda dash sine theta. So the momentum of electron in OA direction is P is equal to h upon lambda dash minus h upon lambda dash sin theta, and in OB direction it is h upon lambda dash plus h upon lambda dash sin theta. Therefore, the uncertainty in value of momentum electron in OX direction is delta P is equal to the momentum in OB direction minus the momentum in OA direction. So the h upon lambda dash cancelled and it equals to 2h lambda dash sin theta. This is equation 2. From equation 1 and 2, delta x into delta p is equal to h upon 2 sin theta, that is equation from 1, into 2h lambda dash sin theta. Here it cancels, so it equals to h. So delta x upon delta p is equal to h, or delta x into delta v is equal to h upon m. That is the uncertainty equation. So this is all about the Heisenberg uncertainty principle and Heisenberg uncertainty equation. The next will be the probability concept. Thank you.